Right, let's focus please everyone. So, today we're going to talk about the linearity property of derivatives. Big word, but it's fairly straightforward, alright? I'm sure when I show you, you'll understand what does it mean. We need to define the linearity properties of derivatives and use it to differentiate sums and difference of functions and solve problems involving instantaneous rates of change and tangent line. Now, when we say y equals 4x to the power of 3, of course you can derive the derivative, can't you? Why don't you do that for me, please, both of them? What is y equals to 4x to the power of 3? What is dy dx? And the other one is 3x squared plus 1. Now, what happens if I split it into 2? If I say this is 4 dot x to the power of 3, the dot product, 4 times x to the power of 3. What do you do with this? Do you differentiate that? You actually just differentiate this. That becomes 4 times 3x to the power of 2. Right? So we don't change the coefficient, but we operate on this. Here, basically is differentiating this to that and differentiating that to that. Right? You know that? So, what we're going to define is if d dx k times function of x, which is 4 times x cubed in this case, is actually the derivative of that is k of the derivative of fx. See? So if you derive that, 3x, that's 3x squared, that's actually 4 times 3x. That's it. 4 times 3x squared, not 3x. So it's basically, this is just a meaning, whatever is there, you multiply using the power rule, multiply that to the coefficient, and then take that away. Let's say take 1 away. And then the derivative of fx plus gx is basically derivative of fx plus derivative of gx. That's all. It's a concept that you've already known, but just formalizing it. Yeah? Happy with that? So, linear combination of functions. A linear combination of function is any combinations that involves the operation of scalar multiplication, addition of subtraction. So the scalar multiplication is the k, the coefficient multiplied by fx. For example, just now, 4 times x to the power of 3, and you derive that is 4 times 3x to the power of 2. Alright? And then the other one is you can add both of them together. Now, so the linearity property of derivatives. The derivative of a linear combination of functions is the linear combination of derivatives. That's it. It's big word, big definition, but the concept is fairly straightforward. You should know that concept already. Agree? Yeah? Alright. Now, I don't expect you to write this down, but just expect you to understand it. So if y equals k fx plus or minus gx, so this is what you get. Derivatives can be applied to linear combinations of functions. One concept, bringing out everything in together. Alright? So let's try the example. You should know how to do this. I would like all of you to try it, please. I'll quickly freeze my screen. Do that, please. Now, pi is actually just a coefficient in this case. It's 3.1415 and so on and so forth. So you should be able to work out the derivative of these two. Combining everything that you know. Sorry?
For A, shouldn't you F?
Which one?
For A, shouldn't you do F instead of dy over dx?
Because I don't say that it's F.
Oh wait, never mind. No.
A is dy over dx because you are given y, so you do dy dx. Whereas if you were given function of t, you do the f dash t. All right. All right. Now, how would you do this one?
So can you go back to this again?
Yeah, sure. Pi is just a number, just a constant. All right. Let's go to this one. There are two ways of doing this. You can. Personally, the way I like to do it is I will take the 8 out. All right, this is the way I like to do it. But you can, this is x to the power of 8 plus 2, x6 minus x to the power of 5. You can also do this. Fine if you want to do that as well. Not a big problem. Whichever way you fancy, that's fine. So I like to do it the first way so that I don't have to worry about the fraction first. All right? And then multiply it by in. All right? So you can either do this way or that way. You will end up with the same answer anyway. So personally, I can say I don't really want to work with the fraction yet. I'd rather do it that way, but it's your preference. Now, finally, this is the last example I have for you today. Let's think about what is exact change. What is average change? What is the instantaneous rate of change? And then you have to find the value of the instantaneous rate of change. All right. Now, question like this, I've seen in exam, it's pretty typical. The word exact change from T1 to T4. Now let's have a look at something like this. All right. What I'm going to draw here is not actually what is there. All right, let's do something like maybe just a graph here. This is y and x. You got one point here. Let's say call this A. Let's call this B. Now, what actually do I mean by the exact change? All right, let's say this is point 1, this is point 4. All right, x is 1, x is 4. So, you know that this is function of x. And therefore, you know this is f1, this is f4. Correct?
Yeah.
Yeah? The exact change is actually just f4 minus f1. All right, the average rate of change is the gradient between A and B, and then the instantaneous rate of change at A is just the tangent line. All right, let's answer this question. So, looking at the exact change from T1 to T4. So x1, work out x1 is 3 plus 5 minus 4, which is 8 minus 4 is 4. x4 equals to 48 plus 20 minus 4. So therefore you've got 16 plus 48, 16 plus 48, 64. So therefore the exact change x4 minus x1 equals to 64 minus 4, which is 60. That is the exact change, the change in y. Now determine the average rate of change. Average rate is the gradient between 1 and 4. So is x4 minus x1 divided by x2 minus x1, which is 4. Let's just write down 4 minus 1. All right. 4 minus 1, which is 60 over 3, which is 20. That's the average rate of change. Instantaneous. Instantaneous, you have to find the derivatives. Let's find x dash t, which is 60 plus 5. All right. So therefore, the instantaneous rate of change equals to 6 plus 5, which is 11. All right. Make sure that you know what does exact change mean, what does average rate of change means, and what does instantaneous rate of change means. So now, find the values of t when the instantaneous rate of change is minus 13. So 60, what am I doing? I don't need a bracket here. 60 plus 5 equals to 13. 60 equals to
Negative 13, sir.
sorry?
Negative 13.
Negative 13, sorry. Minus 18. So therefore, t is equal to minus 3. All right? Now, this is a little bit misleading. There's only one value of s because the derivative is actually linear. All right? Derivative of a quadratic is a linear. All right with that? If you're all right, I'm going to go to the next bit. Same example. Determine the equation of the tangent to the curve at the point 4 and 64. All right? Can you actually work that out, please? All right, you should be able to work out what the gradient is instantaneous. So x4 equals to 6. All right. Now work out the equation. All right. All right. Check my answer. Is that right?
Yes.
Good. All right. Sorry? What did I get for?
The y is negative 52.
Y equals to 29x minus 52.
So I thought it's 52.
116 minus 116 minus 64, that's 52. Is that right?
Yeah.
Yeah. Oh, it looks like root 2. Sorry. Okay, let me write it properly. It's 52. All right. Let's try part B.
Negative 8.
Don't worry about it. I still have one. Actually, you did the normal way, right? You just did like 29 times 4, and then. So you have a straight line, and you know the gradient, and you know one point on that line. So what you do is have y equals mx plus c, the line, original line, and then you sub in those points called line x, and you know the gradient. So the only thing you don't know is the c. You don't know the c. You do. It's 29. Because we calculated the derivative.
I just like spam minus.
It's just another way to do it. Don't worry about it.
What's 29 times
What'd you get?
Mas tu kan lebih belakang. I don't even know. I can't change the time. Sometimes it's okay.
I got 10 points.
All right, you got to deal with fraction for part B. So, sorry? Which one?
It doesn't say part.
Part A, yeah, two part A, sorry, it's part B. All right. So the next part A. Part A number 2, all right. So you got to deal with fraction. So you should, what you need to do is find the gradient first from that this line. All right. So you could rearrange it into y equals mx plus c, and you know that m is minus 4, correct? So therefore, you should be able to work out what t is and substitute t into the function xt. So this is how I solve it. I started off with rewriting it as y equals to mx plus c. First, actually, I divide everything by 2. Make life easier. I divided everything by 2 and went straight to rewriting it as y equals to mx plus c. M equals to minus 4 and work out t equals to minus 3 over 2. Then substitute t equals to minus 3 over 2 into the function. Therefore, you know that x of minus 3 over 2 is minus 19 over 4. And that is your coordinates. All right? I would say that this would potentially be your Calc 3 question, potentially, because you are dealing with a little bit slightly more complex fraction. It will still be in your Calc 3. All right, that's all. Yep, that's all I have for you today. I'll leave it there so that you can actually write it down if you need to. And you should have plenty of exercise in Sadler.
Yeah.